Good morning, student. Today we are going to see a new topic of our exercise first, that is conditions for light ray to pass undeviated. Means when the light ray passes from one medium to another medium, then it will not get deviated by its path, means there is no deviation. For this, what are the conditions that we are going to discuss? First condition, when an incident ray strikes to the surface medium along the normal, then we find that reflected ray goes in undeviated path, in a same path. So the first condition is angle of incidence should be 0. Here you can see that incident ray is along the normal. Along the normal means overlapping of incident ray with respect to normal. Okay, and due to that there is no angle, or angle is 0, or angle of incidence is 0 in this case, right? So if the ray of light strike to the surface media along the normal, then angle of incidence is 0, and this is the first condition which gives us that the ray do not get deviated after refraction. Second, if, or I can say both medium have same refractive index. Both mediums should have same refractive index. Okay, I say should here. Both mediums should have same refractive index. Means if a ray of light passing from one medium to medium 2, if the refractive index of medium 1 is exactly equal to refractive index of the medium 2, then in this case we find the light ray passes undeviated. So these are the two conditions, and the question is asked, take the two conditions in which the light ray passes undeviated while passing from one medium to another medium. Next is relation between wavelength. Okay, relation between wavelength in two medium. Assume that a ray of light is passing from air medium to say glass medium, right? Say AB is the ray, incident ray, strike to the surface media at B, and N dash is a normal, right? Now we find that this ray is going from rare to denser medium, so ray of light after refraction bends toward normal. Now here frequency is constant, here also frequency is constant. Means when the ray of light passes from one medium to second medium, there is no change in frequency. Frequency same. Okay, frequency, there is no change in frequency. But if we talk about the speed of the light in air, it is denoted by c, and the wavelength, say lambda, then f is equal to c by lambda. Okay, a ray of light passing through the air having a speed c and a wavelength lambda passes to the second medium. Second medium is glass medium. So here we find the speed of the light changes to v, and the wavelength also changes to lambda dash. Means here it is very clear that frequency does not change, but the speed of light changes as well as the wavelength will get changed when passes from one medium to another medium. And this is a formula for the frequency. Frequency is nothing but a ratio of speed of light to its wavelength, right? So here what we get, f is equal to what? F for medium 1 and medium 2. Frequency is same in both medium. So I can write C by lambda is equal to V by lambda dash. Okay. Now here I get lambda dash as equal to V into lambda by C. Okay. V into lambda by C. This relation we will get in case of a ray of light passing from one medium to another medium, that is lambda dash is equal to V by C into lambda. Okay. Here, if the ray of light passes from rare to denser medium, a ray of light when passes from rare to denser medium, then we find refractive index is greater than 1. The refractive index is what? Greater than 1. And when it passes from denser to rare medium, then the refractive index is lesser than 1. This refractive index which is greater than 1 while passes from rare to the denser medium, we find that lambda dash over here lesser than lambda. Lambda dash is lesser than lambda. Okay. And in the second case we find lambda dash is greater than lambda. Means here we find the relation between lambda dash and lambda in case of when the ray of light passes from rare to denser and denser to rare. Once again see, if the ray of light passes from rare to denser medium, then refractive index is greater than 1, and we find the relation between lambda dash and lambda as lambda dash, which is the wavelength of the ray of light in denser medium, lesser than the wavelength of the light in rare medium. While the ray of light passing from denser to rare medium, then we find refractive index is lesser than 1, and in this case we find lambda dash is greater than lambda. Means the wavelength of the light in rare medium is greater than rare medium. Okay, so this you have to keep in mind. So this is whole related about relation between the wavelength in the two medium. Now let's see factors affecting the refractive index. Okay, factors affecting refractive index. Factors affecting mu. Mu is nothing but a refractive index, right? Factors affecting refractive index. First factor is nature of medium. Now we know that there is solid, liquid as well as gases, right? These are the three states of matter. Okay, so these are the nature of the medium. In the solid, if I take an example of glass, liquid as water and gases as air, then we find that the speed of light in glass medium is 2 into 10 raised to 8 meter per second, while in water it is 2.25 into 10 raised to 8 meter per second, while in gases it is 3 into 10 raised to 8 meter per second. So due to the different speed of light into the different medium, refractive index also changes. As the speed of light increases, we find refractive index decreases. This is the relation. So this is the first factor. Here what I can say then, speed of light is more in gases, means in air, so refractive index is lesser. Speed of light is lesser in the solid, so refractive index is more. So as the speed of light increases, then the refractive index also increases, right? This is the first factor. Let's discuss about second factor is a temperature, right? Now we know that as the temperature increases, then the speed of light also increases, which shows us speed of light increases, then refractive index decreases. From above relation only we can say, if the temperature is more, speed of light is more. As the speed of light is more, then the refractive index is lesser. Okay, so this is the second factor. Okay, now let's see third factor. Third factor is color. Color of the light, or we can say wavelength. Okay, now we know that the speed of our red color is greater and speed for the violet color is smaller. Okay, speed for a red color is more than the speed of violet color. Now this is in the air. If we talk, then the speed is same for all color, but if the different medium we are considering, then the speed of red color is more than the speed of violet color. Okay, this is the first relation that you have to keep in mind. So the refractive index of the red color is lesser than the refractive index of violet color. Okay, refractive index for the red color is lesser and refractive index for the violet color is more. Means as wavelength increases, जैसे wavelength बढ़ता है, refractive index decreases. You find here the speed of the red color is more, means wavelength is more, speed of violet is lesser. So here we find wavelength is lesser and refractive index is more. So this is the relation, a dependence of this refractive index on color, or we can say wavelength, right? Now next is about the principle of reversibility. Okay, let's see principle of reversibility. Okay, now assume that a ray of light passing from one medium to the second medium, if it is passing from rare to denser, then it bends toward the normal. Okay, now what I do, I keep here the mirror perpendicular to refracted. Keep a mirror perpendicular to refracted ray. Then what we find? It will get bounce back into the same path से वो चला जाएगा, and here again come back like same way. Means this is known as a principle of reversibility. Means rays get reversed over here. Why this happen? Let's see. Refractive index of second medium with respect to first. If I say this as angle of incidence and this as angle of refraction, then by Snell's law, I find the refractive index of second medium is sin I by sin R. Okay. Similarly, if I find the refractive index of the first medium with respect to second, then this sin R upon sin I when the ray going in opposite direction. First, the ray passes from travels a track AB to BC. Now the ray is passing BC to BA, right? So here sin R by sin I. If I do the product of both refractive indexes, so refractive index of second medium with respect to first multiply refractive index of first to second is equal to what I find, sin I upon sin R into sin R upon sin I. Both get cancelled here and I get answer as a 1. So refractive index of the second medium with respect to first is a reciprocal of refractive index of first to second. And this is known as principle of reversibility. Principle of reversibility. So to get a reversible ray while passing from one medium to another medium, the mirror should be placed perpendicular to the refracted ray. Then and only then it is possible. Okay. Now let's see next topic. Refraction through a glass slab. Okay. Refraction through a glass slab. Refraction through glass slab. Assume that a PQRS is a glass slab. One of the ray AB is the incident ray, which incidents initially at the first interface of the glass slab PQ at a point B. Okay. Draw here the normal, which is N dash. First time this ray is passing from air to the glass medium, means air to denser medium. So the ray of light bends toward the normal. This BC shows a refracted ray. This BC acts as an incident ray for the second interface, and it is now going from denser medium to rare. So it goes away from the normal, right? So here we find that if we produce incident ray as well as the emergent ray, then we find both are parallel to each other. What is our conclusion from this diagram? First, a ray AB which is incident at the first interface PQ of the prism makes an angle of incidence I and get refracted or get deviated due to the refraction, making an angle of R. Here it is angle R, and then emerge out from the second interface after second refraction gives us angle of emergence E, or leaves the surface or the medium by angle of emergence E. Okay, so here first observation we get angle I is equal to angle E. Okay, second conclusion from this discussion we got is incident ray is parallel to emergent ray. Okay, incident ray is parallel to emergent ray. This is incident ray, this is refracted ray, and this one is emergent ray. We find here incident ray is parallel to the emergent ray. And third one is the perpendicular distance between incident ray and emergent ray is known as lateral displacement. Okay, so these three things we come to know from this diagram, refraction through the glass slab. Okay, so this diagram is asked for 2 marks only. A prism is given and the incident ray, glass slab is given and the incident ray is given, and the question is asked to complete the diagram till rays emerge out. Okay, so in this way, this is a total discussion about the refraction through the glass slab. Now let's see next topic. Next topic is factors affecting lateral displacement. Factors affecting lateral displacement. So we find that lateral displacement is nothing but a perpendicular distance between the incident ray and the emergent ray. What are the factors on which it depends that we are going to study? So first factor for that is refractive index. First is refractive index, right? So here as the refractive index of the medium increases, then we find lateral displacement also increases. Let's see second factor. Second factor is thickness of slab, glass slab, which you are using for showing this lateral displacement. As the thickness of the glass increases, we find the lateral displacement also increases. So this is the second factor. Third factor is angle of incidence I. Okay, as you increase the angle of incidence, you find that the lateral displacement also increases. This you can check practically in your lab. Next is fourth factor is lambda, or we can say wavelength. Okay, wavelength. Here we find that if wavelength increases, then in this case only we find lateral displacement decreases. Means lateral displacement is lesser for the red color while it is more for the violet color. So in case of the color, if it is asked, then you should remember what I discussed just. Okay, so this you keep in mind. So these are the factors affecting the lateral displacement. Now in this section, the last topic is there, and that is nothing but multiple images formed through a glass slab, and that topic is cut. for this year. So we are not going to discuss this topic, right? Multiple images, about the multiple images. So this is whole about the first exercise, that first video I put, and this is our second video. So this first exercise is over. I will send you the question answers, send you right, and second exercise we will discuss into the next period. Thank you.